In a world driven by technological supremacy, few military innovations have promised as much raw, futuristic power as the US Navy's electromagnetic railgun. A true marvel of engineering, this weapon emerged as a symbol of next-generation warfare, a device that didn't rely on traditional gunpowder or explosive warheads, but instead harnessed the unseen forces of electromagnetism to launch projectiles at hypersonic speeds. But despite over 15 years of development and a staggering $500 million investment, the railgun now sits silent. Not because it failed, but because reality proved even harder than theory. And as the Navy turned away from its electromagnetic titan, another silent killer was stepping into the spotlight: lasers. Railgun. Engineering marvel or miscalculated dream? Picture this: a futuristic weapon platform resting on the testbed at the Naval Surface Warfare Center. A sleek barrel stretches outward like something out of a science fiction movie, but this is very real and very expensive. Unlike traditional artillery, this system doesn't fire shells using combustion. Instead, it uses massive electrical currents to generate powerful magnetic fields, which hurl a solid metal projectile weighing around 7 pounds down 2 parallel rails at speeds exceeding 8,270 feet per second. That's more than Mach 7, faster than most missiles and over 5 times the speed of a rifle bullet. What's astonishing is the railgun's payload: nothing but metal. No explosives, no propellants, just speed. At hypersonic velocity, kinetic energy alone becomes the destructive agent. A direct hit from one of these slugs could mimic the devastation of a small artillery shell, not by explosive force, but by sheer momentum, pushing the limits of possibility. Initial tests were promising. The Navy successfully demonstrated a prototype 8 megajoule system capable of extraordinary precision and power. But the dream weapon was always bigger: a 64 megajoule variant that could someday be mounted on US warships, giving them the ability to strike targets 100 miles away. Compare that to today's naval guns, which might reach 15 to 20 miles on a good day. The railgun, in theory, could hit anything within a massive operational radius: enemy ships, coastal defenses, even aircraft, all without needing explosive ammunition. Yet with this revolutionary promise came crushing technical demands. Each shot drained as much power as a small city block, stressing shipboard power systems beyond capacity. The rails themselves degraded quickly under the extreme heat and pressure, requiring constant replacement. Overheating risks loomed with every firing. By 2021, despite all its promise, the Navy made a quiet decision. Railgun development would be shelved. The costs were too high, the technical hurdles too great. Instead, attention shifted to more mature and practical technologies: hypersonic missiles and directed energy weapons, namely lasers. The laser revolution begins. If the railgun was about raw force, the Navy's laser systems were about finesse: silent, precise, and deadly. On May 16, 2020, the world witnessed the beginning of a new era in warfare. Aboard the United States ship Portland, a drone target buzzed through the morning sky. Moments later, a beam of invisible light fired by the laser weapon system demonstrator locked onto its target. There was no explosion, no smoke trail, just a sudden failure of the drone's electronics as the energy overloaded its circuits. The aircraft dropped from the sky like a toy stripped of power. That test changed everything. For decades, laser weapons existed only in imagination and experimental labs. But now, for the first time, they were operational and proven at sea. Why lasers work where railguns struggle? Unlike railguns, lasers don't require bulky ammunition or massive energy spikes for each shot. Instead, they emit focused beams of light traveling at the speed of, well, light. With enough energy, these beams can disable drones, fry guidance systems, or destroy engines. No noise, no recoil, no explosive risk. Each shot costs just about $1 worth of electricity, making lasers astonishingly cost-effective. Compare that to multi-million-dollar intercept missiles, and you begin to see the strategic appeal. Lasers are also scalable and multifunctional. They can switch between targets almost instantly, deal with drone swarms, and even stop fast attack boats by disabling navigation systems or cooking their engines. Power demands still exist, but they're manageable on modern warships. Heat buildup? A challenge? Yes, but modern cooling systems are up to the task. The new era of defense. The arrival of laser weapons introduces a defensive paradigm shift. In the past, dozens of incoming drones or missiles could overwhelm a ship's defenses through sheer volume. Now, with lasers capable of engaging dodging hundreds of threats without reloading. The balance tips. And lasers don't run out of ammo. As long as the ship generates electricity, the beam can keep firing. This gives them a strategic endurance unmatched by conventional weapons. The implication is chilling. Any nation without this technology now faces a serious disadvantage at sea. Their expensive offensive assets, missiles, aircraft, even ships risk being neutralized by beams of invisible energy. Raw power still has its place. Despite the laser's elegance, traditional firepower still rules the battlefield in certain scenarios. Take the Tomahawk cruise missile, for example, a 1,000-mile range juggernaut capable of skimming just above terrain and hitting targets with extreme accuracy. With terrain-following guidance, these missiles avoid radar and strike deep inland. Command centers, bunkers, supply hubs. 7 different variants allow for specialized missions, from infrastructure disruption to high-value kill strikes. Then there are Mach 54 torpedoes, the Navy's underwater assassins. These beasts weigh over 1,000 pounds and are filled with torpex, an explosive 50% more powerful than TNT. Guided by sonar, they hunt enemy submarines silently, delivering killing blows with terrifying precision. The hit peril. The greatest danger, however, isn't in firing these weapons, it's in reloading them mid-mission. The calm of port rearming is straightforward, but at sea, with decks rolling and wind howling, guiding half-ton missiles into vertical launch tubes becomes a high-stakes gamble. Even a minor slip could mean crushed limbs, accidental detonations, or the loss of weapons overboard. The Navy once used onboard cranes for this, but removed them after too many deadly accidents. As tensions with China and Russia escalate, more ships remain deployed far from home, increasing the need for dangerous at-sea rearming. Sailors train relentlessly for these operations, often in total darkness to avoid detection, knowing a single mistake can cost lives and millions in weapons. Defense in depth. Defense in depth protects U.S. naval vessels through a layered system designed to neutralize threats at varying ranges before they strike. The outermost layer employs long-range weapons like the Norwegian Naval Strike Missile, capable of hitting targets up to 345 miles away. Mid-range defense comes from HIMARS rocket systems adapted for sea use, launching precision rockets and tactical missiles in rapid volleys to overwhelm coastal or fast-approaching threats. As a last resort, the Phalanx Close-in Weapon System, also known as Sea-Ram or Sea-Whiz, unleashes a barrage of 4,500 rounds per minute from its 6-barrel Gatling gun, creating a lethal cloud of 20mm tungsten to destroy missiles just seconds before impact. With enemy projectiles reaching speeds up to Mach 3, this final defense has only moments to detect, track, and eliminate incoming threats autonomously, making every second a matter of survival. The Sky's Wrath. F-35 Lightning II. If all else fails, America's ultimate strike force takes flight from aircraft carrier decks. The F-35 Lightning II. Sleek, stealthy, and bristling with sensors, each of these 5th-generation fighters costs over $100 million. Their radar-absorbent design lets them approach targets undetected. Inside their bays lie precision-guided munitions bombs that can level city blocks or destroy bunkers from 100 miles away. Pilots see through helmets that display all battlefield data directly on their visors, turning them into cyborg-like warriors. The speed, power, and autonomy of these aircraft are unmatched, but such dominance comes with risk. With AI-enhanced targeting, enormous destructive power, and high automation, some worry that these machines might one day become too powerful to control or too tempting to resist using in full-scale war. The balance between brilliance and brutality. The Railgun taught the Navy a hard lesson. Brilliance in theory doesn't always translate to battlefield practicality, yet it paved the way for innovations like lasers, which now stand as the vanguard of ship defense. Meanwhile, traditional weapons, from tomahawks to torpedoes, remain the backbone of naval strike capabilities. And hovering above it all, the F-35 reminds the world that America's war machine can still project deadly force across the globe with chilling efficiency. As technology marches forward, military planners face a sobering truth. Each innovation brings us closer not only to dominance, but also to a moment where machines of war may evolve beyond their masters. The future of naval warfare is already here. The only question is, can we keep up with the weapons we created? If you found this deep dive into the future of naval warfare as fascinating as we did, don't forget to hit that like and make sure to subscribe. Thanks for watching, and until next time, stay sharp, stay informed, and stay curious.